Hey guys, in this video we're in chapter 4 on exponential and logarithmic functions, and we're in section 6 on exponential and logarithmic equations. And in this video we're doing problem number 57, which says solve for x, then graph both sides of the equation and observe the point of intersection to verify the solution. So first thing that we want to do is solve for x. So we notice we have a natural log here, so what we want to do is isolate that natural log. So we'll add 6 to both sides, and we'll get the natural log of 4x minus 10 equals plus 6, 1. Next, we're going to put both sides to the power of e, so we'll have e to the natural log, and that's to cancel out the natural log since e and natural log undo each other. So those will cancel out, and we'll get 4x minus 10 equals e to the first, or just e. And then it's a simple algebra problem. Since e is a number, we leave it like that, and we'll get 4x equals e plus 10, or x equals e plus 10 divided by 4. Cool. So we solved for x. The next thing that we have to do is go ahead and graph both sides of the equation. Now when it says graph both sides of the equation, what we're going to do is we're going to define two functions, and we're going to say y1 of x equals the natural log of 4x minus 10 minus 6, and then we'll have y2 of x equal to the other side of the equation, negative 5. And now all we have to do is graph these and see where they intersect. So the first one's really easy. We're going to graph y of x equals negative 5, and that's just going to be this straight horizontal line through y equals negative 5. Cool. Next thing we have to do is graph this fun equation, the natural log equation. So how we do that is we're going to look at the parent function natural log of x, which looks like this as a natural log. It's going to have this basic shape somewhere along here. And to find the asymptote of where it lies, we're going to set this inside part equal to 1, because we know that the natural log of 1 equals 0. Sorry, we're actually going to set it equal to 0 because we can't take the natural log of a 0. So we have 4x minus 10 equals 0. So we'll get that x equals 10 divided by 4, or 5 halves. So that's where we'll have our vertical asymptote that the natural log is not going to pass. So at 5 halves, we're at 2.5, so we'll have it going like that. Next, we could go ahead and find the X Intercept. So we'll have the y1 of x equals 0, and we're solving for x. So we have 0 equals natural log of 4x minus 10 minus 6 equals that bit. And then we're going to solve for x. So we'll add 6 to both sides, so we'll get the natural log of 4x minus 10 equals 6. And then we'll put e to the power of both sides, and we'll get 4x minus 10 equals e to the 6th. And when we solve for x, we get x equals e to the 6th plus 10 all over 4. So that's going to be where our logarithm crosses the x-axis. And if you put this into your calculator, you're going to get a really big number, something like 100. So what we're going to do is we're going to go ahead and draw the basic shape. And we know that it's actually not going to cross the x-intercept that soon, but it's actually going to go pretty far out before it actually crosses the x-axis. And what we want to notice here is that this x value, when you have this graph precisely, this x, where they intersect, is going to be equal to e plus 10 divided by 4. And that's what it says when it says you want to observe the point of intersection to verify the solution. You verify that where x equals e plus 10 over 4, that's where these two are going to intersect. So that's your answer. I hope you found this video really helpful. The concepts we covered in this video are true no matter what pre-calculus class you take. And the examples I cover are from this textbook right here. And remember, if you're a Baylor student currently enrolled, there is free tutoring on the first floor of Sidrich. You can create a one-on-one appointment online or drop in anytime during our business hours. Please visit our website, www.baylor.edu/tutoring, for more details. Sic 'em Bears.